You're listening to the Cyberwire Network, powered by N2K.
CISOs and CIOs know machine identities now outnumber humans by more than 80-1. And without securing them, trust, uptime, outages, and compliance are at risk. CyberArk is leading the way with the only unified platform purpose-built to secure every machine identity, certificates, secrets, and workloads across all environments, all clouds, and all AI agents. Designed for scale, automation, and quantum readiness, CyberArk helps modern enterprises secure their machine future. Visit cyberark.com/machines to see how. Hello, everyone, and welcome to the CyberWire's Research Saturday. I'm Dave Bittner, and this is our weekly conversation with researchers and analysts tracking down the threats and vulnerabilities, solving some of the hard problems, and protecting ourselves in a rapidly evolving cyberspace. Thanks for joining us.
We have a pretty big user base at the moment, and we have some malware detection systems that are purely based in machine learning. We are constantly verifying samples that we are detecting in the wild that are very different from things that we've seen before. So as part of that process, we found some samples that got our attention, and then we started checking in public sources if we found similar samples.
That's Nicolas Charaviglio. He's chief scientist from Zimperium's Z Labs. The research we're discussing today is titled Behind Random Words, Double Trouble Mobile Banking Trojan Revealed.
So that's how we found around 35 different samples for this campaign, which are from different periods in time of the same campaign. So we could see kind of the evolution of it.
And what is it that made the Double Trouble Banking Trojan stand out compared to others that you've seen before?
There are a couple of new techniques used by these folks, mostly to avoid detection. I'm not sure how familiar you are with how traditional banker Trojans work, but they do implement all the same capabilities. We can discuss them if you want.
Let's do it.
Okay, so let's do that. So recently you had actually an interview with Selena Larson in which you discussed all the info stealers or this family. So banker Trojans are a type of info stealers, but are focusing on financial data, in bank data. So the way they usually do it is they abuse accessibility service on a mobile device in order to be able to tamper with the UI while the user is interacting with a banking application. And the most common attack is what is called an overlay attack. So when the banking app is started, the malware takes control over the UI and puts in front of the bank UI what is called an overlay. So the victim thinks that it's interacting with the regular banking app, but in reality, what is happening is that it's interacting with this fake UI. So all the data that is being entered there, like credentials or account information, is actually being sent to a command and control server. So this is like the traditional attack. In this case, what they did is they added, for example, screen recording capabilities. The reason why they are doing this is because now a lot of malware detection engines are trying to detect on runtime if there is an application that is, for example, using an overlay. So that is something that can be detected. So that renders the traditional banking attack a bit ineffective. So in this case, what these guys are doing is something different, which is to actually record the screen. So they get frame by frame of what the victim is doing. So by doing that, they can reconstruct everything that happened on the device and steal credentials anyway. And you would think that this is pretty similar to an overlay attack, but from the internals of how it works is completely different. So this is something that goes fully under the radar. So this is what basically makes the double trouble more effective than traditional bankers that we've seen out there.
Now, one of the things you highlight in the research is that this has evolved over time. There were, in earlier variants, it was distributed a certain way, and that's changed. Can you walk us through the evolution of the distribution methods?
Yeah, sure. So initially, what they were doing were traditional phishing attack. So the victim had to go through the usually on desktop or on the mobile device, but browsing the web, they had to go through a phishing site that looked very similar to the bank that they were targeting, and basically the user in that social engineering attack was tricked to download an app that was later installed on the device, right? So that was like a traditional method, but in that case the targets were more limited, right? So if you were opening bank A, then you were downloading that app, and you are basically expecting that app to be similar to bank A. So now what they're doing is they are just hosting apps in many different places, and not necessarily as banking apps. For example, they were distributing apps even Discord. So any app repository can contain one of these malicious applications. And the good thing about this is that you don't need to be targeting one specific banking app. You can get the payload afterward. And this is something that we see quite often. So because of the way how the OS protection works, if you download an app from internet, you won't be able and install it on your device. You won't be able, for example, to run accessibility service, which is something that is critical for these malwares in order to operate properly. But what these guys do is like a two stages attack. So first, you get this app from one of these bogus repositories, or it can be any deceptive website. Now, not necessarily targeting a bank, and is what we call a dropper, right? So the dropper has a different application inside that will be installed in a way that is called a session-based installation. And the way to do that, or the benefit of doing that, is that the APK, the actual application, will never be on disk. So if you're a security vendor that are inspecting that, you won't be detecting that because the app will never be there. And now with this dropper, you can kind of like dynamically generate the target. You can contact a command and control server and say, hey, this device have bank A, B, and C installed here. So please give me the payloads that I need in order to target these banks.
Why are they making use of Discord specifically? What are the benefits for the attackers there?
That's a very good question. And sometimes with this research, we don't have all the answers. This is one of them. I guess that they are just targeting like popular social networks. So we see a lot of malware being distributed through Telegram channels, Discord channels. So our guess is that they are like infiltrating specific groups and playing like the good, still the good part of the internet in which people help each other without asking for a lot. So hey, check this, can I help you? And then uh, basically getting some malicious payload with one of these purposes.
I see. Well, the research mentions the use of what you call random two-word method names throughout the code. Can you tell us what that means? And my understanding is that complicates traditional static analysis?
Yes, exactly. So it's basically an obfuscation methodology that they are using. Before, in the compiling process of the app, what they do is they get all classes and method names, and they change them by two random words that they select for each class and each method. Why that complicates static analysis? Because if you usually what security researchers do, they create what we call signature, right? Some heuristic. So if you see this pattern in the code, then it's likely that this is a malicious app. But if that pattern is random and if that pattern keeps changing, then it's kind of like it's very difficult to create that signature. So that's what they are doing. And in this case, it's pretty unusual, but they chose to do this. Like the obfuscation methodology is replacing classes and method names by two random names, each class and each method with a different combination of two words.
We'll be right back.
New adversary tactics and emerging tech to meet these threats is developing all the time. On Threat Vector, we keep you a step ahead. We dig deep into the threats that matter and the strategies that work.
How do they help that customer know that what they just created is safe?
The future is now, and our expectations are wrong.
Join me, David Moulton, Senior Director of Thought Leadership for Uni42 at Palo Alto Networks, and our guest who live this work every day.
We're not just talking about some encryption and paying multi-million-dollar ransom. We're talking about fundamentally being unable to operate.
Automated eradication and containment. So being able to very rapidly ID what's going on in an environment and contain that immediately.
They're hiding in plain sight.
So if you're looking to sharpen your strategy and stay ahead of what's next, tune in and listen to Threat Vector, your front line for security insights.
And now, a word from our sponsor, ThreatLocker, the powerful zero-trust enterprise solution that stops ransomware in its tracks. Allow Listing is a deny-by-default software that makes application control simple and fast. Ring fencing is an application containment strategy, ensuring apps can only access the files, registry keys, network resources, and other applications they truly need to function. Shut out cybercriminals with world-class endpoint protection from ThreatLocker.
USAA knows dynamic duos can save the day, like superheroes and sidekicks, or auto and home insurance. With USAA, you can bundle your auto and home and save up to 10%. Visit USAA.com/bundle.
Bundle savings are off total premium, not available in all states or in all situations. To qualify, auto policy must be active prior to property policy issue, subject to change. Restrictions apply. Membership eligibility and product restrictions apply and are subject to change. USAA means United Services Automobile Association and its affiliates, San Antonio, Texas.
And what is the range of capabilities of Double Trouble? What sort of things can it do?
It can do quite a lot, actually. So we discussed already like the traditional overlay attack. So that is fully present here. And on top of that, it can steal locking patterns. So they have the capability of spawning either the pattern or the PIN code or any password that the user uses. So basically to steal how you are unlocking your device. And this is interesting because there aren't many reasons to do that. But one possibility is that they want to evolve in the future to do something like ransomware, right? So ransomware on mobile devices is discussed a lot, but we haven't seen like any big attack yet. But one way to perform a ransomware attack would be to change the PIN code of our device, right? So if I lock you out of your device and I just display some message saying, "Hey, send this amount of crypto to this address," so that would be like an analogy to traditional ransomware attacks. And Double Trouble has the capability of getting the PIN, the pattern to unlock the device. At the same time, it's a keylogger, so it can record every keystroke on the device. So from there, you can also reconstruct, for example, credentials or any information that you see on the images that I mentioned before. As I mentioned, also we have the screen recording feature, which basically what they do is they're constantly taking pictures frame by frame, and then they are encoding that as base64. So now we transform images to text, and they put that inside of a JSON payload that is being sent to the command and control server with a lot of metadata of the device, so that let the attacker reconstruct everything that happened. And also, it has remote control capabilities. So things that are necessary, for example, to grant the application more permissions. So we mentioned that basically this is like a two-stage infection. First, we have a dropper, and then we have the payload. And the dropper needs to have elevated privileges in order to perform other actions. Not elevated privileges, accessibility permission to do further actions. So once they have that, they have specific commands to control the device, right? They can exercise the UI as if they were, as if they have total control over it. And the last thing that they can do also is they can block and crash legitimate applications. So it's also unclear why they do that, because usually if you're performing an overlay attack, you want the app to be running and you don't want to see any crash. But what they do is they crash the real application and they display a system error message saying, hey, this app is crashing for X or Y reason. And after that, they can spawn a different attack. But it's not completely clear what's the purpose of that stage yet.
And what insights do you have on their command and control functionality and infrastructure?
So usually don't poke much on the CTU. So I don't have a lot of information. I think in the research also we didn't show much on that. We kind of like got through dynamic analysis all the list of commands that they can do, but not we don't have much information on the actual infrastructure yet.
Yeah, fair enough. Who do they seem to be targeting here? Are there any patterns of who they're going after?
So the first version of this was targeting specifically European banks, so all European banks. The latest version, as I said, it's quite dynamic, right? So even if today we see only banks targeted or only European banks targeted, it can happen that the next week that extended a lot. So they have screen recording functionalities. So basically they can target any app, right? So if someone in South Africa is opening this and there is suddenly a stream of information from a South African bank, well, they can go and use it, right? Because they just have all even the keystrokes and all the images. And it's quite common that we see this evolving. Like, for example, a couple of days ago, another security vendor, Clify, they published a blog about a new bank intrusion that is called Play Predators or something like that. And they claim that they found 300 banks targeted. So we did further research for it when we found more samples, and we found that the targets grew from 300 to 3,000, right? So we only found this amount of new targets in just a couple of weeks. So this is a pretty fast evolving ecosystem sometimes. And since they have control on the device, or remote control on the device, the payload can be quite dynamic, and the number of banks targeted can grow pretty fast.
Well, what are your recommendations then for organizations to best protect themselves? What sort of things do they need to have in place?
So in this case, disabling third-party sources is critical. So most of these applications are always coming through embedded sources. So I would say that that's the critical part of it. Never install apps that are through unknown sources or through third-party app stores or things that are not trusted. Second, having a comprehensive mobile threat detection, it can be critical, something that can detect even if the first recommendation is not enforced. And third, in an enterprise environment, having something like application vetting in order to have a comprehensive understanding of what applications that are installed in the user base are doing would be critical too.
Looking at the research that you've done here, what does Double Trouble tell you in terms of where we might be headed in the future when it comes to these mobile banking threats?
That's a very good question. And I think that we can guarantee is that this trend will continue. So this is a cat and mouse game. So attackers will adapt, and we will have to adapt to new kinds of attacks. And we will have to do it in a much more restricted ecosystem every time. So for sure, these attacks will grow in complexity. Probably the extensive adoption of AI will also help to increase the number of targets. So now it's pretty simple for attackers to extend the range of their attacks. So pretty much, I would say that's where we are going, right? Like wider targets and always evolving techniques.
Our thanks to Nicolas Charaviglio from Zimperium for joining us. The research is titled Behind Random Words, Double Trouble Mobile Banking Trojan Revealed. We'll have a link in the show notes. And that's Research Saturday, brought to you by N2K Cyberwire. We'd love to hear from you. We're conducting our annual audience survey to learn more about our listeners. We're collecting your insights through the end of this summer. There's a link in the show notes. Please do check it out. This episode was produced by Liz Stokes. We're mixed by Elliot Peltzman and Trey Hester. Our executive producer is Jennifer Iben. Peter Kilpie is our publisher, and I'm Dave Bittner. Thanks for listening. We'll see you back here next time.